Mark P. Otten back with you.
Okay, this is your other stuff you should know in SEM part 2. Stuff that didn't really fit with other things that you've learned, so I just kind of piled it all into this particular lesson. The focus will be mediation and moderation and those two things in connection with each other. But first of all, I wanted to talk about the possibility of nonlinear relationships between variables. So we operate in stats so often on the general linear model. SEM even operates for the most part under the general linear model because we are making hypotheses about variables being related in linear ways because all of our regression coefficients tend to be linear regression coefficients in that we're hypothesizing as one variable increases, the other will then either increase or decrease. Okay, so this is somewhat unrealistic because we oftentimes have nonlinear relationships that may exist. For example, for me with anxiety, we might hypothesize that a certain amount of arousal or anxiety might be a positive thing for performance up to a certain point, and then up to that point you become too anxious and your performance starts to decline again. And so we had a inverted U hypothesis that in sports psychology is used a lot to try to capture the arousal performance relationship that I just mentioned. This model has also been seen in other parts of psychology, I think, for in terms of maybe test performance and things like that, or other ways. So you might see this hypothesis and then be like, well, the typical general linear model setup for such to model such a relationship is not appropriate. And I saw that when I was making my anxiety performance hypotheses in the past, and I initially ignored it because I was like, well, nonlinear hypotheses are not easily tested. Let's just test for a linear one. But of course, when you do a thesis and eventually a dissertation, you need to cover all your bases. And so I needed to initially hypothesize this as a linear thing, and then later on follow up to test to see if there was a nonlinear thing going on. And so how do we do that? Well, we go back to Aiken and West, who are our advisors on interactions in regression models. They are also our advisors on integrating nonlinear interaction or nonlinear relationships into regression models and eventually SEM. So this last inverted U hypothesis that I showed you was it's a quadratic, right? It's like a upside down parabola there. So we wanted to look at a quadratic relationship potentially between our variables. Generally, for nonlinear relationships here, we need to use a squared term in our regression model, and it sounds more complicated perhaps than it actually is in practice based on what we've already learned. All we do is, well, so this will look familiar. You center your IVs first, and then what you do is, I guess this is just your single IV in a single IV regression. And then you square it after having centered it, and that x squared, or that IV squared, represents the nonlinear effect. So if you get like a B2 in that equation there that you see, that is a significant B2, then you have a significant nonlinear effect. Now the math behind this, I mean, first of all, if you center your IV, then if you're squaring it, you're multiplying it by itself. So a zero, the mean is at 0 when you center it, right? If you're squaring 0, then you're still at 0. So that keeps the mean at 0. And then anything that's positive stays positive. Anything that's negative or below the mean becomes positive also. And so we're changing the distribution of our IV. And so you might, if you're curious about the math behind it, you might start with a graph. You might start with a distribution of your variable, let's say a histogram or a frequency chart. Then you square it and you redo that and you see what happens. That's, I think, the first step to kind of understanding what is really going on here with the squared variable. But meanwhile, there are some rules of thumb. I did mention that all values of x squared will be positive or 0. A large value of x squared suggests just either way that a value is far from the mean, but we don't know if it's positive or negative. The rules of thumb are as follows. So if you get a b1 that's positive and a b2 that is also positive, that suggests a curve that looks like this, sort of concave upward. And those b's, let me flash back to the equation here. The b1 corresponds to the x, that's just the linear term there that stays in the equation, and then the b2 corresponds to the x squared, which is the nonlinear term. So again, if both of those are positive, you're going to see a curve that looks like this if you graph it out between your x and your y. You can also just look at a scatter plot, right, and judge to see whether this might fit. The other scenarios here, b1 positive, b2 negative, will result in a concave down curve like this. The b1 negative, b2 negative looks like so. And then the b1 0, b2 positive looks like this. And then the b1 0, b2 negative looks like this. So I was actually kind of hypothesizing this scenario for anxiety. This fits the inverted U, right, with the b1 0. The b1 0 implies there's no linear trend here, right? Like if you look at a scatter plot underneath this, and you try to draw a line through it, it's gonna be hard to do that, right? Because you don't have anywhere to draw that line that makes sense. So the b1 0 is pretty unusual, but you might see a nonlinear trend in the sense that you might have a parabola either here or the previous one here, the U shape. So more often than not, you're going to see one of these scenarios where you have a non-negative linear relationship as well as a non-zero linear trend, as well as a nonlinear trend on top of it. And so that is indeed what I found with my anxiety performance relationship that I will show you in a minute. So first we have to translate to SEM. We got to center our measured variables again, but this one, so you have a latent variable, right? So you're squaring a latent variable. How do you do that? Well, you square the individual components, the indicators of that latent variable first. This might sound familiar from our talk on interactions in the past, but you center first those measured variables, square them this time. So before with interactions we multiplied those variables by the variables that composed a different latent variable for the interaction. Here you are centering and then squaring. So you're just keeping the same latent IV and you're just then creating a squared version of it. So this is what I had for my dissertation. We had a cognitive anxiety variable. We squared each of those items. Actually, these were squared composites. So this this was a item parceled solution that was then assessed for nonlinearity. You had item 5 squared. That was by itself. You had items 2 and 14 for the second composite. First you create a composite there, and then we centered that and squared it. Same thing for items 8 and 11. Create the composite, center that, and square it. And so you redefine your latent variable there. That's cognitive anxiety squared with 3-factor loadings. Then you have that linear relationship between cognitive anxiety and self-focus. I think I said performance originally. I was actually self-focus, which was the mediator of the anxiety performance relationship, or so it was hypothesized. Anyway, so we had a linear relationship there between cognitive anxiety and self-focus that stayed in there, 0.70. Then we added in the nonlinear cognitive anxiety, composed of the squared measured variables there, centered and squared. And we got a negative 0.35. So we had a positive B1, or linear relationship, and a negative B2, or nonlinear relationship. So if we go back, positive B1 and negative B2, where are we? We are over here. This is your sort of concave downward curve. And so it's like the first half of the inverted U that was hypothesized. So this was pretty cool. We got a nonlinear relationship that kind of made sense because it was like, well, anxiety is going up, self-focus is also going up. This is the which will eventually lead to performance, right? So this made sense, and then it also made sense in the case of our data because we didn't have anybody that was so super anxious to compose the other half of that hypothesized inverted U because we weren't actually putting that much pressure on our participants. to cause them to then go back down in self-focus and thus back down in performance. So we had a nice interpretation come of this, that we had the inverted U, but we only had the first half of it. And the reason we didn't have the other half is because we weren't freaking people out enough. We weren't getting them anxious enough to then start to cause that performance or focus to go back down again. And again, that's because we ran this SEM. I'm flashing forward again here. That's our SEM with the 0.70 positive B1 or linear relationship, and then the negative 0.35 to represent the nonlinear relationship. Okay, so that was the quick and easy introduction to, or no, maybe not easy, the quick introduction to nonlinear relationships and being able to test them in regressions or in SEMs. We also have indirect effects, which are, the term indirect effect is seen often in SEM literature. And so I needed to tell you about it and how it really is just the same thing or very similar to testing for a mediation. So an indirect effect of an IV on a DV is like, okay, A predicts B and B predicts C, so then we can test to see if A predicts C as well. And indirect effects are also popular in the case of like when you have D and E and F, right? You could have A predicting B and B predicting, it's like these long chains of prediction, which are sometimes seen in bigger SEM models. If you just have A, B, and C, then this looks kind of just like a mediation model. But we'll talk about it here because there's some multiplication involved if we do want to test these indirect effects in this way. So if we have A predicting B and B predicting C, then we have regression coefficients for each of those. Unstandardized regression coefficients specifically here are useful. B2 and B3, those are your sort of like the upper half of the triangle in a mediation model. And if you leave them as unstandardized, then you can multiply. So if you multiply B2 by B3 and test for significance, then you can test to see if A is indirectly predicting C through B, like so. So this was an example from Tabachnik and Fidel that involved latent variables. This was a model of like age predicting health care use, and the mediator was perceived ill health. So if you perceive yourself to be in bad health, then you're more likely to use health care, but also there might be a direct effect of age predicting more health care use as well. So this is your like a partial mediation model. If we have these coefficients in here as standardized, we can test for mediation. We don't need the unstandardized coefficients, but in order to test for the indirect effect, we would need the unstandardized coefficients. In this case, B2 0.069 and B3 1.837. We multiply those together like so, and we get 0.127, which doesn't mean a lot by itself, but then we can test for the significance of that value to see if it's significantly different than 0. So the standardized value then that comes out of that is 0.062, and that gets converted to a z-score, which is basically just, what is the purpose of the z-score? Well, we're just trying to get it converting to a p-value, get it converted to a p-value. So R will do this for you, and in this case we see 2.112 for our z-score. That is going to come out to be significant, right? It's greater than, if you guys remember the z, the normal curve, standard normal curve, 1.96, right, is our cutoff point for significance on a two-sided curve. Anyway, that if we convert that z-score to a p-value, we're going to get something less than 0.05, and we see yes. What is the conclusion here? Yes, there is an indirect effect of A on B, or I'm sorry, of A on C, right? In this case, age, there's an indirect effect of age on healthcare utilization through, and it's indirect because it's through perceived ill health. Now this is starting to sound like mediation, right? So if we look at the next slide here, coefficients of indirect effects have complex distributions. This is the math behind it. This is Rex Klein talking from his book on SEM. So complex distribution, so the math behind it is a little bit tricky. because you're multiplying some things together, right? You're multiplying a regression coefficient by another regression coefficient. So how does this come to be? Well, we're consulting the experts here. Barron and Kenny described some statistical tests. We just did that multiplication, right? We've got a p-value to say, yes, that indirect effect is significant. But like, what are the mechanisms behind that? Well, they're basically the Sobel test. So if we go back and we continue on here, the best known of one of these standard error test statistics for calculating indirect effects is basically what the Sobel test does. It's based on an approximate standard error that is the Sobel test. So what's the conclusion here? Thus, basically, if we'd run the Sobel test on our mediation model, then we would have gotten the same answer, essentially, that is significant mediation there, and that also the indirect effect is significant. So, like I said, I think the indirect effect test is uniquely useful when you have more than just A, B, and C. Suppose you have another variable D in the model and you're trying to test for the indirect effect of A on D, then you're doing 3 pathways, right, multiplied together. And in that case, you're getting a test statistic or a p-value for the indirect effect that is going to just test that directly. And you're not necessarily running the Sobel test for mediation on that entire model. And so that's when I think the indirect effect test can be uniquely useful. Here in the mediation case, you're just basically running the Sobel test, which is fine. You're going to get the same answer either way. Okay, so all of this brings us to a discussion of moderated mediation, followed by a discussion of mediated moderation. So these things are, you may have considered or read about one of these cases already in your studies. First of all, there's these two things are separate from each other, right? They're often mixed up. Mediation is when there's a third variable that comes in to explain the relationship between the first variable and the third variable. That's mediation, right? Moderation is when two variables interact to predict a third variable, right? So they're different, but they're both cases. Like moderation involves a second IV, right? Mediation involves a second IV. So they're often mixed up. So then when they're added together, we just need to keep it all straight. So, okay, so moderated mediation is a mouthful. It's basically a mediation model where you have another variable that comes in to interact with the predictor variable on some portion of that mediation model. So there's a couple different scenarios for this. It's known as a conditional indirect effect, if we use the indirect effect terminology here as well. So let's take a look at this as an example. So we're going back to an original example of mediation where enjoyment of stats is enjoyment of stats is mediating the relationship between textbook choice and success in stats. Okay, so first stage moderation of the mediation model is where the first path of the indirect effect, in this case, which textbook you use, influencing your enjoyment of stats, that path depends on something, which is the new variable, in this case gender. So I'm going to turn this mediation model on its side here. We're going to have textbook. I'm just kind of clearing some space so that I can present this in the clearest possible way. Textbook choice is still predicting success mediated by enjoyment. Okay, so that's the mediation model. Then we're adding in an interaction between gender and textbook. What did we say about that? We said that if you are male, only if you are male, which textbook you use influences your enjoyment of stats. So men, for some reason, are enjoying Tabachnik and Feidel's book, and that's influencing their enjoyment of stats. For women, that relationship is not there. So that arrow from textbook to enjoyment is only there for men and not for women. All right, so that's what that gender textbook interaction variable represents there, and then the arrow pointing to enjoyment is representing that interaction or moderation. Now, that's it really for this moderated mediation, but then there's these other arrows that sometimes clutter up these diagrams and make them a little bit harder to interpret. So initially we just have this moderation, like I mentioned. Gender is influencing the textbook to enjoyment relationship, such that only males are enjoying stats more based on the textbook, as opposed to females. There's no such relationship. Okay, so we have that. Then we add in these other arrows. There's a gender effect, or a gender main effect, I should say, that we could add in, such that like gender is predicting enjoyment. Maybe males are enjoying stats more, something like that. And gender is predicting success. Maybe males are less successful than females. I don't know, something like that, right? That nothing to do with the moderation, nothing to do with the mediation there. And then we also have the gender textbook interaction influencing success directly. That's optional as well. That's more like what we're about to talk about next, which is second stage moderation. The second path of the indirect effect depends on the moderator. So here we have how much you enjoy stats influencing your success. That's the second stage of the mediation model, I should say. But only if you are male. How much you enjoy stats influences your success only if you're male. So that was that bottom arrow there. So the enjoyment to success arrow, right? If you are more successful in stats, it's because you enjoy it more, but only if you're male. That's weird, but it could theoretically be a hypothesis. So that's that bottom arrow again. But here we're doing gender and an enjoyment interaction, right, as opposed to gender and textbook interaction. So you just got to make sure that you're specifying second stage moderation instead of first stage moderation, and you're okay. You could also add in a gender main effect as well here, if you want. If you want to be sexist and make a hypothesis about who is better at stats, men or women, you could do that. I will leave that for another researcher to decide. But all right, so in the end, the moderator could come in and influence any and all parts of your mediation model. So we talk about first stage moderation, talk about second stage moderation. We could also talk about the direct effect of textbook to success. That would be sort of like a moderator, but not a moderated mediation, right? It would just be a moderator of the textbook direct effect to success. So but that moderator could influence all of these, which would be a complicated looking model, or it could be only one piece of it, etc. So it's nice to maybe make a checklist if you're running through some of this and you're trying to decide if your moderator influences this or that. Maybe consider each one individually as you're going through. Okay, finally the reverse, which is mediated moderation. So you start with a moderation model here, and then you add in an explanatory variable for the moderation. So we're going to go back to our interaction example here, where we had it was the autism example from a previous lesson. So we'll use that here. Here the interactive effect is mediated or explained, at least in part, by another variable. So here's the autism example. We have verbal and nonverbal skills at 18 months. That's our skills variable, predicting language acquisition at 24 months. The moderator was severity of autism symptoms. So we have only occurring for children with low severity of autism symptoms. That was our moderation setup. And now we have a mediated moderation because we have an explanation, a variable that's going to come in and at least partly explain why this is only the case for children with low severity of autism, and that is because children with autism develop differently. Kind of an obvious explanatory variable here, but we might have this measured in our study. So in this case, we have like a developmental deficit, right? So the difference in their development might be assessed in some way, and so we can include that variable in there as a mediator. So originally we had skills, the skills autism interaction, and autism severity. All three of those were directly predicting language acquisition 24 months. Now we've just split that skills autism interaction into two arrows, and this is actually like a full mediation, right? Because the skills autism interaction predicting language acquisition is has developmental deficit in the middle of it. And so that's a full mediation hypothesis to start with, and then, or I guess a fully mediated moderation is what that is. But then we can add in some other arrows. So again, these kind of clutter up the diagram, but are often included as well. We have some effects here, like, okay, maybe your skills at 18 months might predict your developmental deficit. Same thing with autism severity. Those things were added in by me and my research collaborator originally, because we're like, well, developmental deficit assessment is going to correlate with some other things. In this case, be predicted by some other things. And then that last arrow there is to acknowledge that that mediation might not be a full mediation, right? It might be a partial mediation. So if you look at just the skills autism interaction, the developmental deficit as the mediator, and language acquisition as the DV, if you sort of tilt your head to the left a little bit, you can see the mediation triangle there, right? With those three variables. The developmental deficit at the top of the triangle is the mediator, and then language acquisition is the DV. So that's what a mediated moderation might look like. So in this case, you just take your moderator, your interaction effect, and try to explain it or mediate it in some way with another variable, at least partly. So, all right, that's your introduction to moderated mediation, followed by mediated moderation. I was hesitant to include them both in the same video because they are kind of different from each other, but often said in the same, often considered in the same scenario, because researchers will get them confused and go back and forth between the terms. So if you want, going forward, this is my recommendation. My recommendation is to call moderation effects interactions, because then you get away from this I mean, it happened to me a couple times in this video, right? I tried to say mediation and I said moderation by mistake because they're so darn similar to each other in in letters. So I think my recommendation is to go with mediated interactions for this one, and then the other one, maybe just say a mediation model that includes an interaction. How about that? That might be a little better? I don't know. Okay, so that concludes all my recommendations for now.